Good day, students at home. You're welcome to another episode of Mathematics on School on the Air. Today, we shall be looking at the topic area of plane shapes. What is a plane shape? This is a flat, two-dimensional shape with no thickness. What if something has no thickness? Example is a piece of paper or a nylon. We all know nylon and we know sheet of paper. They have no thickness. So anything of such with two dimensions are referred to as plane shapes. Now, example of plane shapes. The examples are many, but for the purpose of this class, the examples are circle, triangle, square, then rectangle. But as I've said, we have a lot of them. Then, what is an area? Area is a very common word in mathematics, but it has its own definition. Area can be defined as the number of square units occupied by the shape. What's the meaning of this? The area is the number of units that the shape in question will cover if it is placed on a particular ground. One will say square. It can be in terms of millimeter, in terms of centimeter, in terms of meter. So the number of square that the shape is able to occupy or cover, that is the area of that plane shape. Now we want to consider the types of plane shapes we have. So I want to start with a circle. What is a circle? A circle, as you can see on the screen, is a plane shape bounded by a curved surface. If you look at the diagram on the screen, you will see that the edge of this diagram is curved. That's why it is defined as a shape that is bounded by a curved surface. Every part of it is curved. Then, the area of a circle is given by the formula pi r squared. The pi is a constant and it has a value 22/7, while radius is determined by the value given in the question. Now let's go to example to illustrate the calculation of area of a circle. This question goes thus: calculate the area of a circle radius 10.5 centimeter. Definitely we are applying the formula area is equal to pi r squared. Firstly, we have to write out what we are given that we are going to slot into the formula. So the radius is 10.5 centimeter. Our pi is 22/7. Therefore, area is equal to pi r squared, and we have 22/7 times 10.5 times 10.5. We have 10.5 twice because we have r squared. If we multiply 22 by 10.5 by another 10.5/7, we will have 348.5 centimeters squared. Students are advised to be careful of the units because the unit for area is unit squared. Whatever the unit is, you square it. Here we have centimeter as our unit, and for that reason we have centimeter squared. Let us look at another example. Example 2. This one says, find the area of a circle whose diameter is 14 centimeter. In this example, we are not given the radius, but the diameter. This is also possible for us because the relationship between diameter and radius of a given circle. Diameter here is 14 centimeter, but diameter is 2 radius. Definitely to get 1 radius, we have to divide 14 by 2, hence our r is 7 centimeter. Therefore, area is equal to pi r squared as usual. So we have 22 over 7 times 7 times 7. 7 will cancel 7. We have 22 times 7, and that gives us 154 centimeter squared. Centimeter squared and not centimeter. Third example for illustration. Given that the area of a circle is 54 centimeters squared, find the radius of the circle. Here, we are given the area and the radius is required to be calculated. This is also fairly simple. What we need to do here is just to make the radius the subject of the formula. As we can see, area is equal to pi r squared, the formula. Therefore, 54 is equal to 22 over 7 times r squared. We can cross multiply here because 22 over 7 times r squared is a product. So we have 54 times 7 is equal to 22 r squared. So we have 378 is equal to 22 r squared. If we make r squared the subject of the formula, we will have 378 over 22. So we have r squared is equal to 17.18, and our r will be square root of 17.18. R is equal to 4.14 centimeter. Students should note here that the unit here is centimeter and not centimeter squared, because what we are calculating is length and not area. Now we want to go to another plane shape, and the name of that one is rectangle. This is also a popular shape or figure in mathematics. A rectangle is a plane shape with 4 sides where all the interior angles are right angles, that is 90 degrees. This is the shape of a rectangle. Opposite sides are equal and parallel. As you can see, the sign for parallelism there and sign for equality. The area of a rectangle is given by length times breadth, which is given as LB, that is length times breadth. That is the formula for the area of a rectangle. Let's use this example to illustrate the calculation of the area of a rectangle. The question says, calculate the area of a rectangle with length of 8 centimeter and breadth of 5 centimeter. We are going to apply the formula that we have been given, length times breadth, to get the answer. Now, solution. Area of rectangle is equal to LB. Our length is 8, our breadth is 5. So we multiply 5 by 8 and we get 40 centimeter squared. This one is also 40 centimeter squared because what we are calculating is area and not ordinary length. Now we move to another example to illustrate the calculation of the area of a rectangle. This example question says, if the area of a rectangle is 64 centimeters square, while the length is 16 centimeters, find the breadth of the rectangle. This question is not that direct because we are given the area of the rectangle while the breadth is required of us to calculate. This also is very simple to do. Solution. Let the breadth be P. Area of the rectangle is equal to length times breadth. If you slot in the values we have 64 is equal to 16 times P. We have 64 is equal to 16P. When we make P the subject of the formula, we have 64 over 16. And our P will give us 4 centimeters. This means that the breadth will be 4 centimeters if the length is 16 centimeters, for us to have the area as 64 centimeters squared. Students will note that the unit here is also centimeter and not centimeter squared. we'll go to another type of plane shape, and this is called parallelogram. So we are looking at area of parallelogram. What is a parallelogram? A parallelogram is a four-sided shape with opposite sides parallel and equal in lengths. Four-sided, meaning there are four sides, and the opposite sides are equal and they are also parallel. The area of a parallelogram can be got in two ways as a result of the dimension given. What's the meaning of this? There is no one formula for parallelogram that will be used to solve all questions on parallelogram, but the information supplied by the question determines the formula to be used. Now, the first one says area is equal to base times perpendicular height, and this is a diagram. The base here is B, while perpendicular height is H. So we have area is equal to BH. The second case, area is equal to product of two sides and the sine of included angle. The diagram we have here is what the diagram will look like for this kind of question. You have your A, you have your B. And when we say included angle, the angle must be between the two lines that are given, as you can see in this diagram. And the area will now be AB sine theta. Now, let's look at some examples to illustrate the calculation of the area of parallelogram. This question says, calculate the area of parallelogram given below. If you look at this diagram very well, we have the base as 28, we have the vertical height as 7 centimeters, and the slant height another side as 12 centimeters. Definitely there is no angle here, so this is the type of the first case. Solution now. Area is equal to base times height. Our base here is 23, while the height is 7. So we multiply 23 by 7 and we get 161 centimeters squared. Students should note that the area is always in square units. Example 2. Find the area of the parallelogram in the figure shown below. The figure given to us, we have the angle as 106 degrees, while the base is 20 centimeters and the other side is 6 centimeters. Students should not be confused by this type of diagram because the angle given, the line that gave them, are not labeled. But if we use the property of parallelogram, we know that opposite sides are equal and they are also parallel. So the angle is still correct where it is located. So, solution now. Area is equal to AB sine theta. We know our A to be 20 and our B to be 6, and we multiply by sine 106. How do we get sine 106? Sine 106 will be 180 minus 106, and that one will give us 74. So if we use 74, we'll get 0.9613. So the answer will be 115.36 centimeters squared. Solution. The area is given as AB sine theta. So we have 20 times 6 times sine 106. How do we get sine 106? We get that one by saying sine 180 minus 106. So we'll have sine 74. If you look at that one in the four-figure table, we will have 20 times 6 times 0.9613. And our final answer will be 115.36 centimeters squared. The unit is centimeter squared because the dimensions are given in centimeter. Now, summary on what we have done so far. A plane shape is a flat two-dimensional shape with no thickness. This we have explained. Another one Area of a plane shape is the number of square units occupied by the shape. Examples of plane shapes are circle, triangle, rectangle, etc. As I've said, the examples are many, but these are just few. Then, formula for area of a circle is given as pi r square. Pi is a constant, 22/7, and r is for the radius of the given circle. A rectangle is a plane shape with 4 sides. The formula for the area of a rectangle is length times breadth. Then, a parallelogram is a 4-sided flat shape with opposite sides parallel and equal. Now, another one, the formula for the area of a parallelogram are area is equal to base times perpendicular height, while in the second case, area is equal to product of 2 sides and the sine of included angle. Now, assessments. Find the area of a circle whose radius is 3 cm. 2. Calculate the radius of a circle of radius 210 cm squared. 3. Name other 4 types of plane shapes. I hope students at home are writing down this question. So the question again, find the area of a circle whose radius is 3 cm. Calculate the radius of a circle of area 210 cm squared. Name other 4 types of plane shapes. I will be expecting your answer. Till the next time we meet. Bye for now.
Good day, students. You are welcome to another exciting episode of Mathematics and School on Air. Today, by the grace of God, we shall be looking at a fresh new topic, and that is algebraic simplification. Algebraic simplification. You have had to deal with various equations in the past, especially while you are in junior secondary, and as you move to the senior secondary, we will have to step it up a bit in solving equations involving algebra. On today's episode, we shall be looking at how to carry out addition and subtraction of real numbers. So today we are dealing with adding and subtracting real numbers. As a way of warming up, it's our style. Let's quickly take a look at some of these questions. We have this number one, that we are having an absolute value. We have talked about this in the past. Absolute value, when you have these 2 parallel strokes enclosing a particular integer, whatever you have in that enclosed in those parallel lines, whether negative or positive, are always treated as positive, because we refer to them as absolute values. So the absolute value of -3 that we have here is, of course, 3. So we have the answers printed in red there. Okay, and then when you look at this one, now this is the negative of the absolute value of 4 there. So I said whether positive or negative, whatever you have in those parallel lines will be treated as a positive. So we have 4 in those parallel lines. So the absolute value of 4 there is still 4, but that value is multiplied by -1 there. So that ends up what? Giving us a -4. So I hope you understand that, so don't mix things up. If the negative sign comes outside the absolute symbol, then of course whatever you get in the absolute, we take that negative. So that's what we have here. Now let's look at this one. Say write an improper fraction to represent each mixed number. So we have some mixed numbers, and then we have to write improper fraction to represent this mixed number. So here we have 4 whole number 2/3. 4 whole number 2/3. That is 4 2/3. So if we have to express that as a mixed, as an improper fraction. Remember, we have learned earlier that improper fractions are fractions where you have the value of the numerator greater than the value of the denominator. The numerator is the one you have at the top of the fraction, while the denominator is what you have at the bottom. So when you have a fraction such that the numerator has a higher value than the value you have at the denominator, then such fractions are referred to as an improper fraction. So we are to express this as an improper fraction. So what we do is we multiply the denominator by the whole number. Of course, you know how that is done in your elementary mathematics. Add this to it and then make 3, of course, again the denominator. So we have 3 multiplied by 4 to give us 12, plus these 2, that gives us 14, then over 3. So that gives us the improper fraction that we have there. And of course, again here, you can also do the same. So what would that give us? 7 times 7 is giving us what? 49, of course. And then when you add 6 to that, it gives us a 55. So we have that mixed number written as an improper fraction to be 55 all over 7. 55 over 7. All right. Now, let us quickly also look at this one. Now, these ones are improper fractions. They are to be written as mixed numbers. Okay, so now we have 12 over 5. Now you will see that the value of the numerator here is greater than what you have at the denominator. So this kind of fraction is an improper fraction. So to express this as a mixed number, we'll divide this by this. How many times do we have 5 going in 12? Of course, we have it 2 times, leaving us with a remainder of 2. So we have 2 as a whole number, and then we also have a fraction of 2 over 5. So we have 2 whole number, 2 over 5. And so when you try to do the same thing with 9 whole number, 2 over 4 there, that will actually, what you're supposed to have there is not supposed to give you 9 whole number, 2 over 4. So let's just ignore that, and let's ignore that and move on. All right, today, so what's our objective today? Our objective is actually add real numbers and then subtract real numbers. Add real numbers and subtract the real number. That's the major objective for today. And then some of the words we are going to be hearing, probably new ones. Of course, I've mentioned absolute value today, so we'll be hearing absolute value often. And then we'll talk about opposites, and then again we'll talk about additives inverse. What are additives inverse? How do you them? So these are some of the things that we will have to come across today on this episode of algebraic simplification in mathematics. All right, so let's proceed. Now, all the numbers on a number line are called real numbers because we are talking about addition and subtraction of real numbers. Now, so what are real numbers? Real numbers are all the numbers that you can find on a number line. So those are called real numbers. And also you can use a number line to model a particular equation or expression. A number line can be used as a model to express whatever we have in the algebra. And then, of course, we are going to have to talk about addition and subtraction of all these real numbers. So these are the things that we'll be having our hands on today. So first, we are going to have to start looking at addition. Addition. Now, to model addition of a positive number, you know what addition is? It's just about bringing two things together. Summation. 1 together with 2, adding together to give us 3. So that's what addition is all about. So to model addition of a positive number, what we do is we move right from wherever we find ourselves on the number line. So if you're on the number line at a particular point and you need to add a particular unit to the point where you are, so from that point, you move that unit to the right. So that is what we do. So to model addition of a negative number, what we do is we just move to the left. We move to the left. So subtraction. To subtract, to model subtraction of a positive number, what we do is just like the opposite of addition. You know, we say to model the addition of a positive number, what we do is we move to the right. And when you are trying to model the addition of a negative number, what you do is to move to the left. Now, for subtraction, to model subtraction of a positive number, what you do from whatever point you are is to move left from where you are. If you are modeling the subtraction of a real number, of a positive number, and then so model the subtraction of a negative number is just like the opposite of the addition. What you do from wherever you are is to move to the right. That's about how to carry out this addition and subtraction. All right, so we are going to have to start looking at examples. So let's take a look at example 1 here. And example 1 is adding and subtracting numbers on a number line. So it's not just our algebraic addition now. We want to do addition and subtraction on a number line. Okay, so let's look at this one. We have to add or subtract using a number line. And if so, your normal algebra, you just kind of open the brackets and do whatever addition that you need to do. But this one is particularly asking us to add or subtract using a number line. So we have to first draw our number line. Of Of course, you can see a number line drawn here, and this number line is drawn on a scale of 1, 1, 1. All right, so what we have is minus 4 plus minus 7. We have minus 7 in parentheses there. So minus 4 plus minus. So what we are to do is to add minus 4 to minus 7, or say you add minus 7 to minus 4, whichever way. All right, so what we do is after drawing our number line, you start from 0. You start from 0 and begin to move left. Remember, we have said when you are adding a negative value, you move to the left. When you are trying to model that on your number line, you move to the left. And when you're adding a positive, you move to the right. So here we are adding a negative value, 4 from point 0. So I want to add minus 4. So I move from point 0 and then I move to the left to point minus 4 there. Okay, so at this point, this is where minus 4 takes me to. All right, so now getting to that point, I still need to add minus 7 to that minus 4. So at this point, I'm still not convenient. I need to borrow 7 naira more. So I need to add minus 7 to my existing depth of minus 4. So I will have to move again from this point, minus 7. I continue my movement towards the left. And then this time I move 7 units to this. So that's what you can see here. From here, I move 1, 2, 3, 4, 5, 6, 7. And when you see that on the number line, it takes me to what? It takes us to minus 11. So on the number line, going from 0 to minus 4, and then from minus 4 again, taking minus 7 to it, has taken us to minus 11. So if you count from 0, you will actually see we have moved 11 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So because all the movement has been to the left, we have our minus 4 plus minus 7 giving us a minus 11. All right, so that is how to carry out addition of a negative. We have carried out addition of negative numbers exactly in this one. So this can actually help us avoid every form of mistakes that you could probably make when you are trying to carry out your addition based on your normal algebra, your BODMAS, and the rest of them. So if you use number line, it will easily aid you and tell you where you have to get to without making unnecessary mistakes. All right, so let's take a look at another example here. Adding and subtracting numbers on a number line, that's what we are still doing. Example 1b, add or subtract using a number line. Add or subtract using a number line. What we have here is 3 minus 6. Now this is positive 3. Now minus 6 in parentheses. So normally what you do in your algebra is you try to open the parentheses, and then you multiply this by this. It gives us what? It gives us plus, and then you say 3 plus 6 gives you 9. That's what we do normally in algebra. All right, but we're trying to model this on a number line. We want to see how this can be done on a number line. All right, so we start again at 0, and then we move right to 3 because this is plus 3. So from that point we move 3. So if we are kind of moving from minus, okay, if you move from 0 here, if you move 3, this takes us here. But we have actually started moving from minus 3 here. Okay, so it takes us to 0. So we have from minus 3 to 0. So that's about 3 units. And then from this point, if you move 6 steps again, it takes us down there. So if you take this movement from 0, you move 3 to this place, and then you want to kind of subtract minus 6 from that 3. So you have to move from this place 6 units again to the right there, because of course in your algebra, you know, this and this would have cancelled each other out to give you plus 6. All right, so you move from here to here, that gives you 3, and then the other 6 takes us all the way to 9. So we have 3 minus minus 6 actually giving us 9 in that situation. All right, so let's proceed and okay, check this one out. You have add or subtract using a number line. Minus 3 plus 7. Minus 3 plus 7. Now again, we start at 0 and move left to minus 3. Now this is point 0. Now I have minus 3 plus 7. So this is from point 0. I move from point 0, 1, 2, 3 to minus 3. And then after having done that, we now need to add 7 to this minus 3. So from the point where we are, because you are adding to your present situation. So our present situation, we have moved from 0 to minus 3. That's where I am now. I'm indebted to the tune of probably say 3 naira or $3 or whatever units. So at that point, now I am somebody who has now been owing me for a very long time, has been owing me 7 naira. So now decides to give me that 7 naira at the point where I'm indebted to 3 naira. So I am here as a debtor of minus 3 naira now. Now, so the person who has been owing me 7 naira now decides to come and pay me. So that money meets me at the point of indebtedness. So that 7 naira meets me at this point. So it's from this point that I will now add the 7 that has been given to me. So I move to this point. I move to here. So that means I probably pay the 3 naira I'm owing, and then I have 1, 2, 3, 4, and I have 4 naira left. So that my minus 3 plus 7 will give me 4 naira. So we have 4 as a result there. Now, so quickly check this one out. How do I subtract using a number line? Minus 3 minus 7. So again, we start at 0. Now, at 0 here. So minus 3 is the first thing. So I move from there to the left, since I'm subtracting, to the point what? Minus 3. And again, I still need to borrow more, another 7. So I move again from that point again, minus 7 again. I move 7 units again, and then that takes me to, actually this is supposed to be here. I think there's some mismatch there. So this is supposed to end here, so that we have a minus 3. So I have a minus 3 minus 7 will give me minus 10. Okay, so if you just move this line back a bit to this point, minus 3, so this probably will end here. So we have a minus 3 minus 7 will give us a minus 10. All right, so let's look at this one also. Add or subtract using a number line. Minus 5 minus 6.5. Minus 5 minus 6.5. So you start again, move to the left, minus 5, and then again. So if you look at minus and minus again, like we do in our normal algebra, in parentheses, this will change to positive. Okay, so just from that point again, you had your your minus 5 is taking you here. There's a mismatch here. So this is supposed to end here, and then you had your 6.5 again to this side, and you hear that 1.5 here. So that if you have your minus 5 minus 6.5, so you become minus 5 plus 6.5, will give us a 1.5. So that's how just to put all these things on a number line, and then you just work with it, put what you have to put together, and then you will be there with the answer that you need. All right, now quickly, the absolute value of a number is the distance from 0 on a number line. Talking about absolute value, the absolute value of a number is the distance from 0 on a number line, and then the absolute value of 5 is always written as this. I've told you this at the beginning. You have this in a kind of parallel lines there, where you have the number put in a parallel line. So when you talk about absolute value, whatever sign is put there is just considered positive. So you have the absolute value of minus 5 still being 5. If you move here, it will still be 5. If you move here, it will still be 5. That is talking about the absolute value. All right, and then just for you to just quickly look at this before we go today, the adding real numbers. You add numbers with the same sign. If two numbers have the same sign, you add the absolute values and use the sign of the numbers. And then when you're adding numbers with different signs, if two numbers have different signs, you find the difference of the absolute values and use the sign of the number with a greater absolute value. So you have that put in numbers there, 3 plus 6. Okay, and the whole of that put together. All right, so that's just about addition and subtraction of real numbers. All right, so quickly before I go today, I will just have you take a look at these questions here. You are to add or subtract using a number line. You have a minus 2 plus 9. So you have minus 5 minus 3. The third one says a minus 23 plus 42. And then, of course, you have the last one being a 4.5 minus 3.7. You can do that algebraically, and, of course, you can use your number line. But in this case, I'm requesting that you do it using a number line, and when you are done with that, you send it to your answers to the address that rolls beneath your screen, and then I will receive them. But suppose you lay your hand on some other problems and you kind of doesn't find a way around it, you can also forward such questions to the address below your screen, and then you will of course get responses in the next episode. All right, so that's the much time will permit us to take today on this episode of mathematics on School on Air. Until I see you again, from every one of us here,